Imagine a towering Tyrannosaurus Rex suddenly becoming the hunted, its bones crushed by jaws it never saw coming. For over 160 million years, dinosaurs dominated Earth with seemingly unstoppable power. But here's what the textbooks don't tell you. They weren't always at the top of the food chain. Throughout the Mesozoic era and beyond, bizarre and terrifying creatures turned the tables on these ancient giants. A frog with the bite force of a tiger. A crocodile that galloped across land like a racehorse. Birds so deadly they made velociraptors look tame. And a snake so massive it could swallow a car. If you're fascinated by the hidden chapters of prehistory that challenge everything you thought you knew, hit that like button and subscribe, because what you're about to discover will completely reshape your understanding of prehistoric life. Let's dive into the untold story of when the hunters became the hunted. Picture the African savanna 95 million years ago. A young hadrosaur approaches the water's edge, cautiously scanning for familiar threats like large theropods. But danger isn't lurking in deep water. It's racing toward the hadrosaur across solid ground at terrifying speed. Kaprosuchus, the Boar Crocodile, was nature's answer to a question no one thought to ask. What if a crocodile could hunt like a wolf? Stretching up to 20 feet and weighing close to 500 pounds, this wasn't your typical swamp-dwelling ambush predator. This was a terrestrial nightmare with 3 prominent tusks jutting from its jaws like the fangs of a wild boar. These weren't decorative. They were precision instruments that locked their jaws in perfect alignment, ensuring every bite landed with devastating accuracy. What made Kaprosuchus exceptional was its anatomy. While modern crocodiles drag their bellies across the ground, this prehistoric hunter possessed powerful forelimbs and an upright posture. Paleontologists believe it could achieve a sustained gallop, moving across dry land with shocking agility. Think about what this means. Most crocodilians are ambush predators limited to the water's edge. But Kaprosuchus could pursue prey across open ground, chase fleeing animals, and compete with terrestrial predators in their own domain. Its flat, wide skull housed immensely powerful jaw muscles generating a deadly bite force. Sharp, serrated teeth weren't just for tearing flesh, but also for pinning prey to the ground. The long, blade-like fangs at the front acted like daggers, while serrated teeth further back provided the sawing action needed to dismember prey quickly. Powerful forelimbs and sharp claws gave it agility on land, allowing it to strike prey along riverbanks with terrifying efficiency. Its diet was remarkably diverse: fish from rivers, small mammals scurrying through underbrush, and crucially, young dinosaurs venturing too far from their herds. The evidence is written in the fossil record. Bite marks on juvenile dinosaur bones match the spacing and depth of Kaprosuchus teeth. In an ecosystem where dinosaurs seem to dominate every niche, Kaprosuchus carved out its own deadly role, proving that evolutionary innovation, not just size, determined survival in the ancient world. The devil from the swamp. Beelzebufo. Forget everything you think you know about frogs. Forget cute creatures hopping around garden ponds, because 70 million years ago in the sweltering swamps of Madagascar, there existed an amphibian so ferocious that even crocodiles gave it a wide berth. Meet Beelzebufo ampinga, the devil frog, and this name is more than earned. At 16 inches long and weighing over 10 pounds, Beelzebufo was the largest frog species ever discovered. If you held one, it would feel like cradling a small bulldog. But size alone doesn't explain why this creature captivates paleontologists. What makes Beelzebufo extraordinary is what it could do with that size. Modern frogs have notoriously weak jaws, relying on sticky tongues to capture insects. Beelzebufo shattered that mold completely. Biomechanical analysis reveals jaw muscles so overdeveloped that this frog could generate a bite force exceeding 500 pounds per square inch, comparable to a modern wolf. A timber wolf weighs 80 to 100 pounds and can crush bones. Now imagine that same crushing power in a creature 1/8 that size. The physics are staggering. Its skull structure resembled modern Pac-Man frogs, but magnified many times over, with a massive head accounting for nearly half its body weight. This wasn't just about size. The expanded jaw structure and hardened palate created a biological vice capable of delivering crushing force that few creatures of its size could match. What was Beelzebufo biting? Everything. Fossil sites in Madagascar suggest it fed on small birds, lizards, snakes, early mammals, young crocodiles, and juvenile dinosaurs. During the late Cretaceous, Madagascar was home to several dinosaur species, including small theropods and herbivores. Newly hatched dinosaurs, vulnerable and inexperienced, would have been easy targets for a patient predator concealed at the water's edge. The fossil evidence is compelling. Bone fragments found near Beelzebufo remains showbite marks consistent with its jaw structure, suggesting it regularly fed on vertebrates rather than the insect diet typical of modern frogs. The hunting strategy was brutally simple. Beelzebufo would bury itself in mud or conceal itself beneath leaf litter, using camouflaged skin to remain invisible. Its eyes, positioned on top of its massive head, allowed it to observe prey while staying almost completely submerged. When prey came within range, the frog would explode from hiding, its oversized head lunging forward and jaws snapping shut with bone-crushing force. That enhanced sticky tongue would latch onto prey, pulling it into waiting jaws. Once caught, there was no escape. Bones would crack. Struggles would cease. Even its thick, armor-like skin could withstand retaliatory bites from struggling prey. This wasn't just a predator, it was a tank disguised as a frog. The ferocious stalker, Kostasuchus shift to the freshwater floodplains of late Cretaceous Patagonia, roughly 70 million years ago. The climate is warm and humid, with seasonal floods creating rivers, marshes, and temporary lakes. Dinosaurs of all sizes roam this landscape, but hidden in the shallows, partially submerged in thick mud, lies a predator specializing in one vulnerability: youth. Kostasuchus atrox, the ferocious crocodile, measured up to 11 feet long and weighed around 550 pounds. While not the largest crocodilian of its time, what it lacked in size it compensated for with strategy and specialization. This was a creature designed by evolution to target juvenile dinosaurs. Everything about Kostasuchus screamed specialized predator. Its shoulder girdle was massively developed, housing powerful muscles that gave it explosive, bursting speed. Unlike modern crocodiles with eyes and nostrils positioned high on their skulls for aquatic ambush hunting, Kostasuchus had these features positioned more forward, suggesting it spent significant time hunting on land in open environments. Its body posture was another departure from typical crocodilians. While modern crocs sprawl with legs splayed to the sides, Kostasuchus carried itself in a more upright stance, allowing faster, more efficient movement on land. It could walk, trot, and even sprint short distances, crucial for its hunting strategy. The jaws, long and narrow, were powered by extraordinarily strong muscles capable of piercing through the thick skin of contemporary dinosaurs. But the jaw structure suggests a quick, decisive killing bite. rather than the prolonged death roll of modern crocodiles. When Kostasuchus struck, it aimed to end the struggle immediately. The hunting strategy was a masterclass in patience. Kostasuchus preferred shallow waters where thick mud could conceal its dark, armored body. It would lie motionless for hours, even days, conserving energy through slow metabolism. When herds of herbivorous dinosaurs approached to drink, adult dinosaurs were wary, but juvenile dinosaurs lacked experience. They were curious, playful, easily distracted, and perfect prey. When a young hadrosaur wandered too close, Kostasuchus would strike in less than half a second, surging forward with powerful legs and muscular tail, snapping jaws around the neck, and dragging its victim into deeper water. The filter-feeding giant, Stomatosuchus. Not every predator relied on sharp teeth and crushing bites. Some evolved strategies are so bizarre that they challenge our understanding of what makes a predator dangerous. Enter Stomatosuchus, a crocodilian so strange that when its fossils were discovered in early 20th century Egypt, paleontologists struggled to comprehend it. German paleontologist Ernst Stromer, exploring the Bahariya oasis before World War I, unearthed massive bones and an enormous skull unlike any crocodilian ever found. Stomatosuchus likely exceeded 33 feet in length and weighed over 13,000 pounds. But it was the skull that truly baffled scientists. Imagine a crocodile head stretched impossibly long, thin, and flat, resembling a massive board. The lower jaw was extraordinarily broad and flat, earning comparisons to a colossal plow. Unlike the fearsome jaws of other prehistoric crocodilians, Stomatosuchus's mouth seemed almost comically harmless. The upper jaw had 2 rows of tiny teeth, each measuring only about an inch. The lower jaw was completely toothless and featured a structure remarkably similar to a modern pelican's throat pouch, a membrane of elastic tissue that could expand dramatically. So how did an animal this massive survive? The answer lies in filter feeding. Stomatosuchus wasn't a pursuit predator or ambush hunter. It was a living net, swimming through shallow coastal waters with its enormous mouth open, straining fish and small aquatic animals from the water. The feeding process would have been mesmerizing. Stomatosuchus would glide slowly through schools of fish, jaws agape. Water and prey would pour into its mouth, filling the expandable throat pouch. Then, it would force water out through gaps in its jaws, trapping fish against a filtering mechanism formed by tiny teeth and specialized tissue. But here's where things get interesting. While Stomatosuchus lacked tools to actively hunt dinosaurs, its massive size gave it another option: opportunistic predation. When smaller terrestrial animals, including juvenile dinosaurs, approached the water's edge, this giant could swing its massive head violently, creating powerful water surges that would knock small animals off balance into the river. Once in the water, even a relatively harmless mouth could hold prey underwater until it drowned. The terror birds, when dinosaurs' descendants turned predator. Here's an ironic twist. Some of the most dangerous predators of dinosaur descendants were themselves dinosaurs, or more accurately, the direct evolutionary descendants of dinosaurs. After the mass extinction event 66 million years ago wiped out non-avian dinosaurs, the world entered a new era. In South America, isolated from other continents, a group of birds evolved into something truly terrifying. Forest racids, commonly known as terror birds, were apex predators that ruled South America for nearly 60 million years. Standing between 5 and 10 feet tall and weighing up to 550 pounds, these flightless birds were built like nightmares. Imagine an ostrich with the proportions of a grizzly bear, a massive hooked beak that could shatter bone, and legs capable of running 30 miles per hour. The anatomy of a terror bird was a masterpiece of predatory engineering. Long, powerful legs with massive thigh muscles provided explosive acceleration and sustained running speed. A tall neck allowed them to spot prey from great distances. And that beak, that massive axe-like beak, was their primary weapon. Unlike the beaks of modern predatory birds, terror bird beaks were reinforced with thick bone and powered by immense jaw muscles. They could use these beaks in multiple ways, pecking downward with enough force to crack skulls, seizing prey, and shaking violently to break necks, or repeatedly slamming prey against the ground until it stopped moving. But here's the crucial detail. Terror birds didn't just hunt mammals. In the post-extinction world, some dinosaurs survived. Small theropods, particularly in isolated regions, managed to persist for several million years. These survivors, along with early birds and other dinosaur descendants, became prey for terror birds. In a sense, one branch of the dinosaur family tree evolved specifically to hunt other branches. Terror birds employed pack hunting strategies in some species, similar to modern wolves, coordinating attacks and using speed to run down prey. The reign of terror birds came to an end around 2.5 million years ago, when the Panamanian land bridge formed, allowing North American predators like big cats and wolves to migrate south and outcompete them. The titanic serpent Titanoboa. In 2009, paleontologists working in a coal mine in northeastern Colombia made a discovery that would rewrite our understanding of how large snakes could grow. They unearthed fossilized vertebrae from a snake so enormous it challenged the limits of physics and biology. When they reconstructed the skeleton, they realized they were looking at an apex predator with no equal. They named it Titanoboa caragenensis, and it lived approximately 60 million years ago, just after the extinction of the dinosaurs. The numbers are staggering. Titanoboa reached lengths of up to 43 feet and weighed over 2,500 pounds, roughly 10 times heavier than the largest modern anacondas. This snake could look a giraffe in the eye. It was long enough to span a school bus. How did a snake grow this large? The answer lies in the climate. Titanoboa lived during the Paleocene epoch when global temperatures were significantly higher than today. The Colombian region experienced average temperatures around 90 degrees Fahrenheit, creating a hot, humid, tropical environment. Snakes are ectothermic, relying on external heat sources to regulate body temperature. In warmer climates, cold-blooded reptiles can grow larger because they can maintain higher metabolic rates without expending energy to generate body heat. The warm Paleocene climate essentially removed size constraints that limit modern snakes. Titanoboa was a constrictor, related to modern boas and anacondas. Its hunting strategy was brutally effective. Ambush prey near water, strike with lightning speed, coil around the victim, and squeeze. With its immense strength and massive body coils, it likely compressed its prey's circulatory system, cutting off blood flow to the brain and causing rapid unconsciousness. Death would follow in seconds. What did Titanoboa eat? Everything it could catch. Giant turtles, massive crocodilians, large fish, and early mammals. But here's the connection. Titanoboa lived during the same era as some surviving dinosaur lineages. Small theropods, early birds, and other dinosaur descendants that survived the mass extinction now faced a new apex predator. The bigger picture: why dinosaurs weren't invincible? Why could these non-dinosaur creatures successfully hunt and consume dinosaurs? The answer requires looking at the broader ecological tapestry of prehistoric Earth. Dinosaurs, for all their size and power, operated within complex ecosystems where they faced constraints like every other organism. First, consider environmental diversity. During the Mesozoic era, Earth's continents constantly shifted, creating a mosaic of different habitats. Large theropods dominated open plains and forests, but struggled in deep swamps, dense wetlands, and shallow coastal waters. These marginal environments became refuges for other predators. Crocodilians like Kostasuchus and Kaprosuchus thrived in wetland edges where dinosaurs were at a disadvantage. Second, think about life stages. Adult dinosaurs were formidable, but young dinosaurs were vulnerable. Every dinosaur began life as a hatchling lacking size, strength, and experience to defend itself. They were easy prey for specialized predators targeting the young. Crocodilians perfected this strategy, sitting patiently at water sources where young dinosaurs would inevitably come to drink. Third, consider metabolic advantages. Dinosaurs likely had elevated metabolic rates, giving them speed and stamina, but also meaning they needed to eat frequently. Cold-blooded predators like crocodilians and giant snakes could survive on far fewer meals, allowing patient, energy-efficient hunting strategies that dinosaurs couldn't match. Fourth, evolutionary innovation matters more than raw size. Beelzebufo's incredible bite force, Kaprosuchus's terrestrial adaptations, Terrorbird's speed and coordination all represented evolutionary solutions to specific ecological challenges. Dinosaurs were innovative, but didn't have a monopoly on evolutionary success. Other lineages found their own paths to dominance, exploiting weaknesses in dinosaur defenses or filling niches dinosaurs overlooked. Finally, remember that dominance is always temporary. The fossil record shows no species reigns forever. Dinosaurs ruled for over 160 million years, an extraordinary run. But throughout that time, they shared the world with countless other creatures, many perfectly capable of killing them. Conclusion: rethinking prehistoric power dynamics. The creatures we've explored today represent just a fraction of diverse predators that thrived alongside or after dinosaurs. Each tells a story of evolutionary innovation, ecological specialization, and the constant struggle for survival that defines life on Earth. These predators challenge the simplified narrative about prehistoric life. Dinosaurs weren't unchallenged rulers. They were participants in complex food webs where success depended on adaptability, not just size. The hunters could become the hunted. The dominant could fall to the specialized, and bizarre creatures that seem impossible by modern standards could thrive for millions of years. What's perhaps most remarkable is how these predators shaped dinosaur evolution. The constant pressure from crocodilians, amphibians, and other threats likely drove dinosaurs to evolve defensive adaptations, herding behaviors, and protective parenting strategies. Evolution is an arms race, and every predator creates evolutionary pressure on its prey. The dinosaurs we know from fossils were the survivors whose adaptations allowed them to coexist with these other predatory lineages. As we continue discovering new fossils and developing better analytical tools, we're constantly revising our understanding of prehistoric ecosystems. Every discovery adds another piece to the puzzle, revealing a world far more complex and fascinating than we imagined. The predators we've discussed are just the beginning. There are undoubtedly countless other creatures waiting to be discovered, each with its own unique story of how it survived, hunted, and competed in the age of dinosaurs. So the next time someone tells you dinosaurs were the ultimate predators of their time, you'll know the truth. They were incredible, successful, and dominant, but they weren't alone at the top. They shared their world with an array of predators just as fearsome, just as deadly, and in many cases, just as successful. The age of dinosaurs was never just about dinosaurs. It was about the entire interconnected web of life, where every creature found its place in the grand story of evolution. Which of these prehistoric predators impressed you the most? Could you imagine encountering a terror bird face to face, or being stalked by a galloping Kaprosuchus? Drop your thoughts in the comments below. Thanks for watching, and I'll see you in the next one.